Hello class, I hope you all are doing well and we are only 1 month away from the final period. So I encourage you to keep up your great work, and if you have missed some assignments or quizzes, I urge you to take action and complete them as soon as possible, because as it gets close to the final period, it's just going to be harder for you to catch up, especially considering all other exams and projects are coming up for your classes. Okay, so take action and start now. Um, and when you submit your missed assignments, please give me an email or a message, so I will add your grades. Okay, in this video, I want to focus on this Unit 7 assignment to explain some basic concepts about regression and also explain the code. So regression basically is to find the relationship between the target variable and the other variables. Um, this could be the relationship between y and could be a relationship between y and the multiple variables that could be x1, x2, x3. They're called multiple regression. Okay, multiple linear regression. If this is y equals ax plus plus b x2 or plus c x3, then that's called a multiple regression. However, we could focus on the relationship between y and just one variable. Then this is called a simple regression. Also, for regression, you could it could be just a simple linear regression that is y equals ax plus b, right? This is a simple linear regression. Or it could be y equals ax squared. This x could be a square and plus b x plus c. That is called a polynomial regression. So in this assignment, we are just focusing on this regression, okay? Simple linear regression. Okay, so if we have lots of data points, we have a lot of cases, and if the x and y shows that their shape is probably roughly aligned, then this is a good fit for simple linear regression. Of course, if the dots, you plot a scatter plot and then the xy shows a curved shape, then which one would be a better fit? It's a polynomial regression, right? Okay, so that's how we identify which regression is a better fit for the problem. Okay, but here we are focusing on this one. Okay, let's have a demo for a case. So here I have some data. So here I have a data set of fish. So this one, it has a lot of cases, probably over 200 cases, and each case represent one fish and has its weight and with its length and height and width. So what we are trying to see if is which variable is influencing the weight. Okay, which variable will be a good prediction for the weight. So X could be these variable, one of these variable, and Y is the weight. Okay, then the first thing we want to find out is how could we identify which variable is a better X, a better indicator for the weight. So that for that purpose, we have to use a concept correlation. If one of the variable has high correlation with the weight, okay, then this is a better predictor, right? Okay, so how do we do that? Let's open the Colab, Google Colab. Okay, open a new notebook. Let's upload this data set first. The first thing we are going to do is to read in this data set as a pandas data frame, right? PD and then PD dot. Okay, and the name is I will name this data set data frame as DF data frame, and you can predict you can preview. Okay, it looks we read in this data set successfully. So how can we find the correlation of each variable with the weight? Actually, the data frame, the pandas data frame has a function called a correlation. Okay, if we use this function, it will return the correlation coefficient of each variable with the y value. So as we see, all the diagonal values are 1. That's because weight and weight can be explained as a y equals x. So the correlation is a perfect correlation. The number is 1. And here these actually all have high correlation with the weight, except this height is a little bit low. So if I need to drop some variable, I'll drop a height first. So which one is the best variable to predict weight? Which one has the highest correlation? That's this column length, right? Length and the weight. Its correlation number is correlation value is 0.92. So it has the highest correlation with weight. So here I'll use this column as x and then weight as y. So define x equals the f and we are already very familiar with the function ilog. Okay, help me to get this column length 3. Length 3, we want to get all the rows, and then after the comma, it's the column number. The column number is 0, 1, 2, 3. So it's 3, 2, 4. Let's take a look here. Be careful here. So we could just use 3. That also gives us this column. However, what it gives us is a 1D theory, a 1D data theory. Okay, but if we use this 3 to 4, this still gives us one column because the end number is not included. So this still gives us this column. However, this X is returned as a data frame, as a 2D array, 2D data frame. Okay, but when you use the values for the linear regression, you need to use 2D array. So here I'll use 3 to 4, or else you may need to use reshape. That will be more complicated. Okay. Next let's get to y value. Y value, we still use the DFI log, and we want all the rows. And the column number, help me to find the column number. The weight is the first column, so it should be a 0. And we only need one column, so it should be 0 to 1, right? Okay. Okay, looks correct. Now the next thing we are going to do is to use this XY to train the linear regression model. So this function linear regression, it will find the best line, that fit for this dots. So it could be here, it could be this, and the function, this machine learning function will find the best line. Okay, so how do we do that? We need to import this function. Opt linear model. Okay. Next, we can use this function, and we name this trained model as a linear regression fish. Okay, and then we call this function and use the XY to train the model. Okay, that's all. All right, looks the code has no problem. So after we train the model, we should get a linear regression line, right? So how can we get the linear regression line? So, which means that we want to know if you want to explain the linear regression line in math, how do you explain this? This is the y equals x plus b, right? If we know the a and know the b, then we know how this line goes, right? Okay, so next one we are going to do is to obtain the a and b. A is called the slope. Slope, if we can get this slope by calling this attribute, and this will return the a. Okay. And next one we can call the intercept, and this will return the value b. So now we have the a and b. You know how to draw the line, right? The line should be a line. The equation for the line should be a y equals a, the coefficient here, 28.46, x plus the interception is minus 4. Okay, so this will be the line that we have drawn. The best line that fits this all these dots. The next thing I want to do is we can visualize this. We can visualize these scatter plot dots, and we can visualize the original x and y, and then we can visualize this fitting line to see how this line is fitting for these dots. Okay, so what we want to do is to get, so we can easily get to the scatter plot, that is to use the x and y. So how can we do this line? The line, the x is still same, the x, but the y should be, these are the predicted y. Right? So what we need to use to draw the line is to use the x, but use the y predicted value as the y. Okay, so let's do that. Next one. Scatter plot. Let's obtain the y predicted value first. Okay, and the model we have trained is called LR fish, and use the LR fish we can predict the original x, and it will give us the y values, the predicted y value. Okay, we can compare it with the original value. See, this is 306, and the original value for the weight for the first case is 242. So there's still some distance, right? This is still quite a bit difference. And let's visualize these x, y, and see how it fits. How good or how bad this model is. Okay. What do we need to do is to import the library from matplotlib pyp plot. Okay. And the plt we can plot the scatter plot with the original x and y. Okay, that's not a problem. Here it shows this scatter plot. And now next one, we want to plot the line plot. The line plot uses a function called plot. And the x is still the x, but the y should be the predicted y. Okay, let's see how it works. We can use a different color. Okay, so this is the fitted line. Fitted line for these dots. What do you think? I think it pretty much fit for these dots, but not perfectly, right? So how can we evaluate really whether this can we quantitatively evaluate whether this line fitted well or not? So there is a matrix called R-square score. R-square score usually measures the y predicted value. Y predicted value are on this line. So we use this equation, right? So this is the line, and this is the y value we get with this linear model. So this y predicted value here on this line, and these are the y true value. We want to see whether the distance between the y predicted and the y true are large or not. If it's large, that means that it's not a good fit. If it's small, okay, then this line, pretty much a good fit for all these dots. So this matrix called R square. I think then this is a function we use R square score, and to use this R square score, get this R square score, we just need to give it the y true. The y true is this line we have defined here y true. Right? And the y predicted, we have predicted it here, right? Okay, so we just use this variable called y predicted. Right, I think that will work. So this returns as R score, there is a 0.85. So for the R score, if it's closer to 1, that means this line fit perfectly. If R score is 1, that means that this line fit perfectly. And if the R square score is closer to 0, that means that it's a bad model to predict. Okay, so because you can understand it as the y predicted value and the y their distance are very large, so it's not a good model. Okay, so in this case, the R square score is 0.82, 85. So it's a high score. So that concludes my video today. I hope it helps a lot. And if you still have any question after watching this video, feel free to email me or text me. You got my number. That is 678-390-4022. Okay. We can just troubleshoot on the phone, or we can set up video meetings. But the most important thing is you started now, so you have sufficient time to figure out the problems you may meet. Okay.